We are going to look at percent composition by mass in this video, and this will correspond to page 11 of your homework packet. So I'm going to look first at water or H2O. So let's say I had a mole of water here. Okay, in that mole of water, I have 6 times 10 to the 23rd molecules of H2O. So I just looked at H2O, I'd say, hey, there's twice as many hydrogen atoms as oxygen atoms. Okay, that is true. But by mass, because oxygen weighs more than hydrogen, there's a bigger percentage of the mass of water comes from oxygen instead of hydrogen. So by number of atoms, what, the 66, 67%, okay, or 2/3 hydrogen, and 33% or 1/3 oxygen. Okay, by mass, it's a different story. And we can see here, if we look at our results, it's only 11%, okay, percent by mass hydrogen and about 89% mass oxygen in H2O. And that's because oxygen is a lot heavier. Let's take a look at how we figured that out. So to do that, the first thing we do is just figure out the molar mass. But this is good where it's good to write the components because we're going to use those as we do it. So I'm not going to go to a periodic table, but the molar mass of oxygen and hydrogen is 1. We have 2 of them, so 2 times 1 is 2. And oxygen, we have 1 of them, and the molar mass is 16. So 1 times 16 is 16. So 2 plus 16 is 18. That's the molar mass of water. What fraction of this mole of water, so I have a mole of water, it weighs 18 grams, 2 of those grams come from hydrogen, and 16 of those grams come from oxygen. So oxygen by mass is the biggest contributor. What do I do to figure that out? I just take the 2 divided by 18, and that'll give me a decimal, 0.111, repeating, but then I times that by 100, and that's where I get the 11 or 11.1%. Okay, again, I take the 16, the mass for oxygen divided by the total mass, which gives me 0.8888, repeating, but I times that by 100 and I round and I get 88.9% oxygen. Okay, these two numbers should add up to 100%, okay, or be very close. Sometimes it doesn't quite because of rounding, but it should be close to 100% because those are the only 2 components that make that up. So that is the percent composition of H2O by mass. Okay, I'm not going to do number 1, C6H6. That's a benzene ring, equal number of carbons and hydrogen atoms, yet because carbon's heavier, over 90% of the mass comes from the carbon in that, because carbon atoms are 12 times heavier than hydrogen atoms. And then I'm going to do number 2 in this video, just to get some more practice at this, and I'm going to find the percent composition by mass of the carbon and chlorine in CCl4. So that is this molecule. It's carbon tetrachloride, carbon combined with 4 chlorines. So to start that, I'm going to find the molar mass. I'm going to do this here. And again, I'm not going to look up on the periodic table, but I'm going to say carbon. If I look that up, I don't want to take the atomic number of 6. I want to take the mass of 12, one with all the decimals. And I'm going to say 1 times 12 or 12.0 equals 12.0, and that would be my mass for carbon. I'm going to do the same thing for Cl, and I'm going to say Cl, but this time I have 4 of them, and I'm going to say times, and I think the mass is 35.5. You can look that up to verify that, and that's going to give me 142 right there. So if I had 142 and 12, I'm going to end up with the total molar mass of 154, and I'll say grams per mole for CCl4. So right away, I'm looking at this and saying, wow, CCl4, there are more chlorine atoms, but chlorine is also heavier. So the vast majority of this mass is going to come from the chlorine. It's not just a 4-to-1 ratio, it's even bigger because chlorine is heavier. So what am I going to do? I'm going to take this 12 and divide it by the 154. So I'm going to do that over here. and do carbon first and say 12, the mass of the carbon, the contribution of carbon divided by 154. That's going to give me a decimal, so I'm going to times that by 100, and that's going to equal, I believe, 7.8%. So my mass is going to be 7.8%. Now, without doing the next one, because there's only two things, my guess is this is going to be what, 92.2% to add it up to 100. So I could really stop there and do that second part, but I'm going to just double check and make sure. So I'm going to take the 142 and then I'm going to divide it by 154, times that by 100, punch that in my calculator, and I do come up with 92.2%. So it does make sense these things would happen there. So even though I have 4 times as many chlorine atoms, okay, the percent composition is even a bigger difference because chlorine weighs more than carbon. So that's what I did to figure that out. What if you have 3 things like in this? Just find the molar mass and then just do 3 parts and you can figure out those percentages, but they should all add up to 100%. Okay, hope this helps and let me know if you have questions. Thank you.